Uh, So, and last actually, just do 2 seconds. So the last lecture we covered only 4 pages. So we'll start from the new one. It is our C. Okay. Sorry for the last lecture if you guys put the whole online for that. And then really I'm sorry for that. So welcome you again. We'll start from here. From C or the noble things I want to tell you here is that we will not go very deep in the concept of the small concept. The things that we are going to cover, I know they will come in the basis in the activities. Now we'll cover later on in detail. So for now, we can keep them just for the line. How is it look like? I put it just because of the okay, silk pattern. So what is the silk? You already know that there was a two classification regarding the terms. You see regarding with the soil set, right? First one was by USDA, United States Department of Agriculture. The second one was from ISS. So there was the site mentioned about the sea. That site was by USDA, the size was 0.052, 0.00, and by ISS, the size of ship was, what was that? This same was by USDA, this was the size for ISS. So there is a simple trick I told you earlier, right? Silk always come just before the thread. So what was the range for clip is just 0.02 and then less than in clay case. But in silk case, we have to follow one of ranges. They is start from where? We start from 0.02, simple as that. So this is the size of wave that we already discussed. So what is the specific surface area? We already discussed about the there was the in same area that much particles, there is only this particles. So this is the surface area, there are different particles contain also surface area. So surface area is a quite highly comparable same. So what is there? There is 1.1 meters square per gram and seen by simple microscope. Sand was seen by nectars and seed is seen by simple or normal microscope. Microscope. Right. Then the next thing, see very simple and normal microscope. Determination by the sedimentation. What is sedimentation? Velocity depend on gravity. Sedimentation. We're gonna discuss this lecture ahead. I think not in this lecture, but in the next one, we will be talking about the what is the sedimentation, right? Other properties about the cities. No cohesiveness, non-sticky, same like same, but it have bit of higher comparison to sand, but non-plastic as well. Follow? So these properties are carried by silicon. Let's jump to the big one. Why I did not focus on these things, we already discussed in the previous lecture that the Jupyter also done. Okay, so this is the important one from where you can see the questions. So we go through with very much focus on that will be key one. So particle size is the first thing we learn in the classification, always 0.00. The trick was write to and put 20. Simple or like very fine particle? Yeah, we know that between three of same length the smallest size. Extremely high surface area. We know that about it also because there was a concept size is directly proportional to surface area. Opposite size is direct opposite to the surface area, like simple as that. Correct? So clay is the smallest size, that's why the surface area is highest one. Provide large contact area for water retention, nutrient retention, and chemical. Yeah, there is a lots of surface area, so it provides a large area for chemical retention. Correct. What about the capacity? You want to know that it creates this problem. It creates this small pore space. They are small in the size, so it holds the water for the longer time. So it create the micropore. That micropore is known as water retention pore, water holding pore, water retaining pore. So they hold the water. Okay. Okay. Movement retention, CC. Okay. High kinetic sense capacity. High kinetic sense capacity because surface area is large. So they can provide the large area at the same time provide the large area for the chemical reaction. So this coming the right. What is chemical reaction? They are talking about like physical reaction, the same like water retention. Right. I get an exchange capacity can work something that I take care of about it. Make clear soil fertile. It depends on the if CC is high, it's your then fertility yours are simple as that. Keep in mind, we're not gonna keep into this here because we'll cover these things later in the alright. So clay have high fertility. Make sure manage there is a line also mentioned manage well. It should be managed well, but there should not be restriction for the plastic shipping and providing. Plastic when wet, when the clay soil, when clay soil is wet, then plasticity is high. It can be molded into any desirables. Correct? Plasticity is what? Ability, ability of soil to be molded and desirable symbol. So it it has the capacity of plasticity. For example, stick together due to the particle attraction. There are the two particles, they are very small. They do have a lot of attraction between them. So that attraction between the particle is from soil particle and soil particles. Clear soil particle to the soil particle. That attraction is from coefficient. That is high in place, right? Right. Drainage and aeration. So drainage and, and aeration is poor. Yes, sir. What is the reason? Of course, there are water retaining pore. Water retaining pore, water flowing pore, let's refer the micropore. okay, which hold the water, which won't facilitate the water moving. They don't want to go through it. They just hold the water, hold the water, and so make the drainage. Yeah, that's the reason. There is a high cohesiveness, there is a high addition, so they hold the water for the longer drainage system. Yeah. If micro hold the water, so if the water in the pore, so air will be less. So low air and micro good poor drainage water slowly and good aeration, good suffocated into service problem. Yeah, so basically there will be lots of water. So there will be the deficiency of the oxygen, then roots will be suffer from the heating of from the aeration or respiration problems over time. Less people swellings will take behavior. Clay contain tuber type silicate clay. What is this things? Silicate clay minerals and all we discuss in very detail. way. But this is the one mineral called what polyamine. Alright? Um, it has the capacity of swelling and sinking and shrinkage. So that's why J has the capacity of swelling and shrinkage. Correct? Explicitly like moon modular swells when the weight and sinks when the drive in both the ways. Why it happens? Swelling is because of weak bond in between the weak bond in between the tetrahedral or octahedral. So, sorry for that. But it high nutrient holding capacity, but nutrient holding lock of sodium acid and what related what is meant high nutrient holding capacity are holding acid. The reason high surface area because it provides a high surface area so that getting access capacity for the to hold the nutrient for the longer time, right? But maybe lock the what related to acid for life. What is meaning of it? If soil is acidic, acid, there is nutrient called phosphorus. The soil is acidic. It is high in aluminum or iron. They do get by aluminum phosphate or iron phosphate. Like they make a combination with it complex and make phosphorus available in the soil. So in that case, there may be like they lock the nutrient, they, they will not provide to the plant for their requirement. So in this case, in acidic soil, it happens. So that's why it's saying, but nutrient may not be so is acid. And poor irritated, how treatment, like if water is there, the fluid, like it's plant, and water is filled. So there will be the path of not taking, there will be it will be the lack of oxygen. So that's the factor is the specific surface area 11 to 1100 meters square per which is very high in comparison. Seen by electron microscope. This is the window. Electron microscope. There was seen by normal microscope, same by types. But what in case was sorry, what in case is uh, it's seen by electron microscope. So particles like ideal like particle or ideal like how kind of how this look like left or ideal like this is about the point right. Clear fraction. In short, what is the summary? What is the theory? Very fine particles with the high surface area, high water retention, plasticity, corrosion, poor drainage, and potential of simple shredding. This is the correction of the what we study on the board. Heavy soil refers to the soil that are which is the clay particles and high clay. Heavy soil. We already discovered. Let me just explain. Heavy soil which require high power to grow, for which require require more power, power, cultivate. It's even just because of the cohesion is high, soil, soil required high power for the release, high power for the cultivation. That's why for the friction. Light soil, same. Two. I forgot to tell you about what I was trying to report. So, poor irrigated soil, how it can affect the local fertility of soil. So, imagine that there is a water condition. The other factor I told you is the process like with the just imagine that there is a water filled in the microphone. So what happens? There is a nitrogen. There is a nitrate present in the water. So in poor aeration case, the nitrate will cover into the nitrogen. So it's a dioxide or simple element. So that will make because can't take nitrogen as complex or three minus. So this would be unavailable to the plant just because of the poor aeration. Correct? Let's have so it refers to soil that are which in clear particles that have a high reflecting. They are for maybe because their but density is in front of our other strong productions. So one of them have requirement power to fertigation, requirement fertigation is all. Next step is for active fraction and the body is the possibility. Active and passive soil fraction. Active fraction. What is active fraction? The active fraction refers to the smaller soil particles that are chemically and physically active. Namely, clay and fine silt, which strongly influence water heating, with holding capacity and cation sense capacity. What does mean by that? So active fraction soil refers to the smaller soil particles. We know what is the smaller soil particles are? Clay and silt. They are chemically, physically active. They are chemically active because how it is possible chemically active because C, C, pH, or sorry, yes, C, C, uh, in physical case, water for liquid holding. So it take place, it do participate more in these kind of activities. So it is a highly active. That's why we call it active fraction. And physically it will mainly clay and fine slip just like with what we call the okay. Which we take to participate in the ion exchange because the reason was mentioned already earlier, the surface area is high. Yes, all right. Ratio correction is what ratio correction refers to the four soil particles may be same, which are less reactive physically and chemically. Yeah, the surface area is less. They will not take place very much in an excel of data in excel, like the AC. In an AC is high force segment. These come from like scientists. To it's a number of productions. So we are not posting website. Size decreases with the porosity. They will check. Size decreases. Size decreases with the porosity. What is meant by that? So we discussed there are the two kind of host form particle and when the area is same and the number of particles of particles and the size of particle will be different level of soil. So which contain the high porosity. There there are only two soil particles. So this there are two soil particles which cover the much area in this area. We have the same area here, but there are the particles are behind and except because the size is smaller, the surface area is and the pore space is also in between, but it's here this one is mentioned in pink color. So, so let me mention and so this is the same. So this is the color. So where is the pore space is now? Where the particle size is not? No, the particle size is small. So surface area is opposite to the size, right? So pore space, yeah, yeah, surface area also like it's the same surface area and porosity. Both are opposite just of porosity is just opposite surface area. Sorry. Porosity is just opposite to size. Size increases, then porosity decreases. Size decreases, the porosity, simple. Size decreases, porosity increases, size decreases, surface area of the porosity capacity. Type of pores, micropores, the size is 0.06 mm, being 0 sometimes it becomes like this size you weight, like the we can do on 40 feet. Generally, water person. In micropore, the size is like this. Generally, water person or generally okay. In micropore, generally water person, and that's really water dependent. Alright, water person. Micropore size is more than 0.06 or 1 the urban general here is personal problems. It's like critical importance of science field according to different problems. We'll go through the one by one. First, we'll go with the porosity. What porosity cell was? What is the porosity in the next liquid? We just took a decent example, but we discuss again. In this way, there are the same particles like this. This is the where are the particles? The same area. So for whole space or empty space, that is known as whole space. In this area, they mention such empty space, space or whole space. They is in counter total area that is blanket the small particles, that is known as whole space. So which shows that the more surface area according to when we calculate the total surface area, this area would be the density. So the soil is stay and the soil is same. The size of the maybe there could be bigger centimeters, but the number of what I'm saying just focus on the size of bone and number of size of floor is larger in same number of floor is maximum. So then we count when total surface total porosity total porosity that is maximum. Farm numbers, right? So what would be the sequence of porosity? Porosity. Sequence. So what will be play role in maximum porosity because porosity is just opposite to the size. There's a small size range called the maximum porosity. Then silt, then sand. I think I got sand or the maximum for larger size, there's porosity. Good. That sequence is created by micropores, micropores, these pores, micropores, these pores. So in same case, it's in micropores. In case there is a micropore. So this is the simple. So A is the maximum micropores and then say the same. Same is the medium particle of the is so what is micropore? What is the sequence of micropores? The sequence of micropore is send voltage micropore. So you send silk when the size increases, micropore increases. Of filtration, filtration different. This soil is one of microphones. It's hard. Right. So, food was the reason is they do not have addition too much or it reinforces food. So, what will be discipline? Same as the microphones. Then see, yeah, simply just on OS, filtration, that is filtration. Yes, it's directly proportional to microphone. Surface area, we already discussed that. It is a surface area and same. Water molecule capacity. Water molecule capacity. Water molecule capacity is directly proportional to surface area. Which one has a larger surface area? So it's we this soil contain the clay. Who told me that's so we'll go with the you first and see and say. Drainage we will discuss about right? Okay. Yes. Plasticity. Plasticity is directly proportional to clay content. If clay is more, it's sure, it's sure plasticity. Definition we already know. It's a rigidity of fluid. So UV voltage. I design about say. Let's say, right? So this is the capacity of soil fully mounted completely level of say. Where it happens, to soil then like particles. Particles. Alright? The place now when plasticity is more. So plasticity we have good say some. What about the pollution and radiation? Your particle radiation is high. They are very close to each other. But they are not the larger insane gap between the particle is more. That's mean low potential. In play, gap is very low. That's mean potential is very high. Right? And addition, the whole space, there is a micropore, this is the micropore. The friction between uh, soil particles and water between in case of the micropore and lower between in case of the micropore. So micropore is a hard, micropore is high sandy soil, and the micropore is high clay soil. So the basis of the progressive addition into high cell shading as from the we already know polymer uh, is found in very cell and it's clear that cells are here. What happened in the cell? Why they not same clear? Oh, let's just go to the when it comes to the wind development. We know that the attraction between clay particles is high because of cohesion side. So they will not easily detach with each other. What is erosion? Erosion, it is right. Sorry guys, I will be otherwise if I go to these concept too much deep, then lecture will be very long. So I don't want to be something like the mistake I did the previous one. So we done these things very short. So what I was telling I should not go for the use of it. It was very good, like use of problem I had very big. So why did you the best loss of time now in the story lecture? So the mistake I did in the previous lecture. So we only talked the 4 pages. Otherwise, my focus was like my to complete in one lecture, but place. Okay. We want to know wind erosion. What wind erosion said? The cohesion is very high actually. So we do not replace to each other very easily. But in same case, it is low cohesion cohesion. So particles detach easily. So so if wind in this wind low, then particles move with the wind and cause wind erosion. So once say not of the first place, there is silt entry here. The reason is that in silt case, the cohesion also is same like same, but the same particles are larger in the size. So it requires more energy to move on the surface to make movements for the same particles will require more energy. But in case of same particle, they are smaller in size. They go very easily melting. So less energy required for the silt catchment comparison to the same problem. So that's why the silt come on the first place. Correct? Then same And clay is in the dust. The wind erosion is very low in clay just because of the high poison. It's and the hard mass. So like water erosion. In case of the water erosion, I think the silt soil is on the first place, the second place, the same. Everything is changed here. Silt is remains the same. So what is that? Why it come up into a cell? Imagine there is a cell where this particles. So silt will come with them and will force through these pore space and it will make soil crust. Soil crust is a very interesting topic. We cover and it's a hard failure. The model three local spaces that is between the sand or clear particles. They measure that after that, if rain happens, then runoff would be possible for soil cycles, which will be responsible for water will not move downward in the soil profile, not will be entered into soil profile, so it will be close to sea erosion, it will cause the water erosion. That's because of that. So when silt is on the first position, right here, right here is on second position. Silt is on the first position, there is why silt is like lesser. Let me tell you. Sand, we did study about the IBM. What was that? Sand is larger micro save high drainage capacity for the water. So when the water will come, it will pass through easily between the sand because the micropores are not like water hitting. They conduct water through same particles very easy. So they will be part of the possibility of water loss. So that's the reason why sand is important. But in case of clay, clay hold the micropore, which is the water retaining pore that will cause so water will fill fill in the micro growth, then it goes to water erosion for glacier. So just because of that. So, I think we should end the lecture here, otherwise it will go on too long. We'll look over the short teaching classes in the next lecture. They will be fast. They will just take the time. Then otherwise, in cover over this lecture. Right. Thank you for signing off.